You are welcome to the GMAT 41's physics class. And I hope you had a wonderful day at school today. And for those who went to work, I also hope that you had a great time at work. In our class today, I'll be teaching you equations of uniformly accelerated motion. This is actually part 2 of motion. In part 1, which was in our previous classes, we learned about the average, the instantaneous, and the uniform quantities of motion, like speed, velocity, and acceleration. In this part of motion, our interest is to deal with equations of uniformly accelerated motion. So whatever the acceleration is, whether it is instantaneous, whether it is average, whether it is uniform acceleration, we are referring to all of them as acceleration. Now, in this aspect of motion, our interest is to learn about the 3 major equations of motion. The 3 equations of what? Motion. We have the first equation of motion, we have the second equation of motion, and of course the third equation of motion. As we move on into this topic, I shall teach you how to derive these equations. Of course, you know in some of the exams you sit for, it might be necessary for you to derive these equations. You might be asked to derive them. Think about your WASE, West African Senior Secondary Certificate Examination, also called WAEC. Think about something like NECO. Think about even your own terminal exams. Your teacher can ask you to derive the equations of motion. Is that clear? Well, talking about JAMB, you are not there to derive anything. However, it is not out of place for you to know how these equations are being derived. And so, let us now get set as we move into it. Are you ready? The first equation of motion. There we don't have any much problem. We are going to take our mind back to the definition of average acceleration. But remember, like I said, in this part 2 aspect of motion, equations of uniformly accelerated motion, we don't refer to anything as average acceleration, instantaneous, or uniform. We take all of them generally as what? Acceleration. So, if you remember, in our previous class, we defined acceleration as the rate of change of velocity. And when we wrote the formula, we stated that acceleration is equal to velocity final minus velocity initial. That is final velocity v minus initial velocity u divided by t. That was actually average acceleration, you remember. But I've said this, and I'm still repeating it again. Here we are not using any particular term to define the acceleration. We simply call them what? Acceleration. And here on the board, I have that formula that I'm talking about. So from this definition of acceleration, we can actually get our first equation of motion by making the final velocity v subject to the formula. How do I do that? Now we know that acceleration is equal to v minus u over t, where v is final velocity, u initial velocity, and t is the time interval or the time taken. So from here, if I cross multiply, just mathematics, making something subject of the formula. If I cross multiply, we'll have that v minus u is equal to at. This times this is equal to v minus u. Then making v subject of the formula, minus u will cross to the right hand side of the equation. And of course we know if negative crosses equality sign, it changes to what? That's correct. So this is going to be equal to at plus u. You can still write this as v equal to u plus at. They are the same thing, is that okay? So this gives us the very first equation of uniformly accelerated motion. We simply call it the first equation of motion. That v is equal to u plus at. The meaning of the terms have been defined here on the board. We don't have much problem deriving or establishing the first equation of motion. So let us now move on to the second equation of motion. In the second equation of motion, our interest is to establish, to get the distance covered by an object in motion. Please, take a look at what I have on the board here. In the second equation of motion, we are taking s to be the distance covered in a given time t. And we are taking v bar, this v with something like minus on top, a dash on top. We're going to take it as average velocity. Remember, like I said, in this second equation of motion, our interest is to get the formula of distance covered. But first, let us define our average velocity. If you hear the average of anything, it's simply to add up the number of things you have there, then divided by the number of things. For example, I have these 2 markers on my hand, right? If I want to take the average of these markers, I'm just going to add both of them. It's going to be this marker plus this marker, and then I will divide both by what? 2. That's how we take average. It's still the same as mean value of something. So when we talk about average velocity, it's going to be the initial velocity u plus the final velocity v divided by 2, because there are these 2 velocities we talk about here. And so let me do that. Average velocity v bar is equal to u plus v divided by 2. Let me call this equation star. I'm going to call it equation star. Now, we are going to do something to this average velocity. I know the value of final velocity v. That is given by equation 1, the first equation of motion. So I am going to write but I know that v is equal to u plus at from the first equation of motion. Therefore, I'm going to substitute for v, substitute for v in equation star. Remember, you can label your equation with whatever you choose to call it. The choice is yours. Now, in substituting, it implies that this is the symbol for mathematics implication. It implies that our average velocity v bar will now be equal to the initial velocity u plus, in place of this final velocity, I'll put this term, u plus at. I'll open brackets and put it, u plus at. Alright? Then I am going to divide this by 2, because the average velocity from equation star is divided by 2. If you work on this, what will you get? This is going to give us equal to u plus at divided by 2. I opened up the brackets. Please let me say this quickly, because it's always good to do the right thing. Even if sometimes doing that thing may not affect anything, or not doing it may not affect anything, but it is good to do the right thing. That is why whenever I'm having a formal class, I try to show the right thing. Look at this part that I enclosed u plus at in brackets. I may choose not to put it in brackets, and it won't affect what I am working on. Reason, because the sign before it is plus. Now, why did I decide now to enclose it in brackets? Because I like doing the right thing. I want students to know the right thing. Some persons may go ahead not putting this in bracket. Well, because this is plus, you'll be safe. But if this were to be minus sign, you'll get into trouble. Because if it is minus and you don't enclose u plus at in brackets, the mathematics interpretation of that is that the minus is affecting only this u, which is not true. Are you following? And that actually have created a lot of trouble for some students. So please, let's remember to always do the right thing. If you add u plus u, you're going to get 2u. So that our average velocity will now be 2u plus at divided by 2. I'm going to take this as equation star star, double star. This is another way you can write the average velocity of an object in motion. But my interest is to determine the distance covered. So how do I bring in the distance? Well, it's very simple. Are you getting it right? We are going to introduce the definition of distance covered. Now, but we know that distance covered is average acceleration, average velocity rather, times time. So I'll say, but distance covered s is equal to average velocity times time. Remember that we could still say that average velocity is given as, in terms of this, as distance divided by what? Time. Just like we saw under speed. Are you following, right? Just like we saw under speed. Alright, so let's call this equation triple star. That is star, star, star. So what do I do? In this equation star, 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 which now gives me the value of the distance s, I am going to replace the value of this average velocity with equation star, star. So I will now say substitute equation, let me abbreviate please, equation star, star into equation star star, star. Hey dear students, it's very important for you to learn how to derive equations. Are you getting it right? Very important. Some exam questions you might just encounter, like I stated from the beginning of this class, could just be derive so-so equation. Are you following, right? And for this, you need a good knowledge of mathematics. So don't joke with maths, whatever course you're going for. Now, let us look at what we do here. This implies that my distance s will be equal to, when I say substitute equation star star into equation star star star, it means I should pick this equation star star and then fix it into equation star star star. This equation double star defines average velocity for me. This whole thing is average velocity. So if I am putting it into equation triple star, anywhere I see average velocity, I would put in this whole value 2u plus 8t divided by 2. Can we do that? So this becomes equal to, in place of this v bar, I will open bracket and then put 2u plus 8t divided by 2. Then remember that the average velocity in this equation triple star is multiplied by t. So I'll multiply by t. Now let us see what this gives to us. If you work on this, we are going to get, by opening up the brackets, this is going to give us s is equal to, if you open up the bracket, this t, we multiply this 2u to give us 2ut, and then plus, it's going to multiply this 8t to give us 8t squared. You know, t times t will give you t squared. Then you divide this by 2. Let me now show you something in mathematics. If I have x plus y divided by 2, it's the same as x over 2 plus y over 2. Which means you can split the numerator over the denominator. In the case where the numerator is combined by plus or minus. So I'm going to apply this knowledge here. You can see plus here, so I'm going to split that numerator into two parts. And so this is going to give me 2ut divided by 2 plus 8t squared divided by 2. This 8t squared over 2 is the same as 1 all over 2 8t squared. What will happen here? This will cancel this. And therefore, we're going to have that s is equal to ut plus 1 over 2, that is 1/2, times 8t squared. This will be equation 2. And this is our second equation of motion. Let me indicate it. Second equation of motion. So you see how we derived it, okay? Fine. We are now set to derive the third equation of motion. Let us look at how we do that. We are going to derive the third equation of motion. We've already established the first and the second equation of motion. We shall use the knowledge of this first and second equation of motion to derive the third equation of motion. Here on the board, I have the first and the second equation of motion. So, how do we proceed to get the third equation of motion from these two equations? It's a simple one. Let us see how we go about that. We're going to start by using the first equation of motion, which is equation 1 here. I shall square both sides of the equation, the left and the right hand side. So let me write that, square both sides of equation 1. So in squaring both sides of equation 1, this is what I do. Watch. It's going to be v squared equal to, pick these two terms together, which is u plus 8t, and then square it outside. This is how we square both sides. Please, I want to tell you this clearly. Don't go do this. When you hear square both sides, you now go and do v squared equal to u squared plus a squared times t squared. This is very wrong. And that is why the GMAT 41 will always continue to advise any science student, whatever the course you want to study in a higher institution, to make sure you take mathematics seriously. Please, don't be among those who say, no, I'm going for medical field. I am not going for engineering. I'm not studying pure mathematics, so I don't need maths. Please, dear students, take note. In a higher institution, as long as you're a science student, you've got no choice. You must be trained in mathematics. For those of you preparing for JAM, that is University and Tertiary Matriculation Examination, your physics, your chemistry, calculations you do there are done using the knowledge of mathematics. So please, even if anyone tells you, don't worry, you're going for medical field, you're an art student, forget about maths, I don't be bothered about maths. Please tell the person that the GMAT 41 said what? No. You have to work on maths. Take it very seriously, please. It's going to help you a lot. So, this is not correct. Let us see how we expand this. I've shown you need to put all the right hand side in bracket and then you square it, being that you have plus here. So, this is going to give us v squared. I'm expanding now. I'm going to expand the right hand side. V squared equal to, in expanding the right hand side, what will I do? I'm sorry, I'm going to use the knowledge of binomial expansion in mathematics. I'm going to use the knowledge of binomial expansion. It's going to be u squared, then u times a times t times 2. U times a times t times 2 will give us plus 2uat, and then plus this term at squared, which will give us a squared t squared. What I did here, don't try it for power 3 and other powers. Don't do that. It only works for power 2. However, there is a better way of solving this, even without using what we call combination or Pascal's triangle. On the binomial theorem in mathematics, I'm going to teach those of you that enrolled for mathematics. However, I am urging all of you, get the link to our mathematics class, our further mathematics class, so as to be guided on mathematical principles. It is for your good and you will never regret it. Is that okay? Anyway, having said that, let me quickly show you this. You can still choose to expand this by doing u plus at. You know, this is squared, so you multiply by itself again, u plus at. So that you have u times u, which is u squared, and then you have u times at, which is uat, then at times 2, which is another uat. That uat plus the first uat will give you 2uat. And then at times at will give you a times a, which is a squared, t times t, which is t squared. Like I said, there is a faster way using binomial expansion to get this, which is what I've done. Let us move on, please. At this point, I am going to factorize 2a from these two terms. Are you following, right? So let me write it. Factorize 2a, factorize 2a from 2uat plus a squared t squared. Then someone might be wondering, who has the knowledge of mathematics, why can I factorize 2 from here? There is no 2 in this term. Yeah, I can factorize a because there is a here, there is a here, but there is no 2 here. I have only 2 here. So why would I factorize 2 from these terms? It is possible. This is mathematics. Now let me quickly show you something about factorization. Something that maybe you may not have known before, but if you knew it before, good enough. Still an added advantage. If you have 2x plus y, if you look at this, is there anything common to both of them? Think it's only one that is common. This whole term is times 1. This one is also times 1. So there's only one that is common. 2 is not, x is not, y is not. But what if I choose to factorize 2? Can I actually do that? The answer is yes, I can do that. As long as I know what factorization is all about. And today I'm going to show you what factorization is about. If I say that 2 is common here and I want to factorize 2, I'll bring out that 2. How will I know the terms that will be inside the bracket now? These 2 that I brought out, I'll use it to divide these 2 terms that I'm factorizing 2 from. So this is going to give me 2x divided by 2 plus y divided by 2. Now you notice that these 2 and these 2 will cancel out, and this will give us what? 2 bracket x plus y over 2. If you open up this bracket, you still get this. This is the principle of factorization. Like if I gave you 2x plus say 2y now, and you say that 2 is common, you bring it out. To know what should be inside the bracket, it's going to be 2x divided by the 2 you brought out, plus this 2y divided by the 2 you brought out. So this is the mathematics of factorization. This will go with this, this will go with this. This is the mathematics of what? Factorization. Whatever you are pulling out, use it to divide where you are pulling it out from. With that, you can factorize out anything, whether that thing is there or not. Alright, let us do it here and see. This will give us v squared equal to u squared. Then coming to this, plus I have factorized 2a out. What will now be in the bracket? The 2a, I will use it to divide 2uat. If you divide 2uat by 2a, you are going to get ut. And then plus divide a squared t squared by 2a, you are going to get a t squared divided by 2. How did I know that I'm going to get a t squared divided by 2? Watch. A squared t squared divided by 2a. This a will cancel 1 from the top, from the numerator. You know, this a is a times a. This a squared is a times a. So one of it will divide this one under. So you'll be left with 1a on top, then t squared divided by 2. Alright, now that I've done the factorization, I want you to watch this bracket very well. Do you agree with me that this bracket is equal to the second equation of motion, equation 2? Look at it. It's the same as this term. And this term is defining distance s for us. So what will I do? I will simply substitute for this whole bracket. In place of this bracket, I'll replace it with s. So alright, replace the bracket, replace the bracket. And what's the bracket? That is ut plus 1/2 at squared. Replace it with the distance, with distance s, which is our second equation of motion. Therefore, what we are going to get will be v squared equal to u squared plus 2a. Then this whole bracket, you fix s there. And this is the third equation of motion, equation 3. Let me indicate it. Third equation of motion. Third equation of motion. Third equation of motion. And of course, we are done deriving the three equations of uniformly accelerated motion. It is now time we're going to see how we use them to solve questions. And I want to believe that you are ready, prepared for that.